In the last video, we talked about descriptives, and this part we're going to talk about the linear regression. So the first is that we're going to go back and look at the data again. So the data is like this. So we have the opioid use over time, right? For each hospitalization. And also we have the dates here. We have the admission dates, and because we only show here, we only show the first 10 observations, but the time is going to go on and on. So we might have the interest, for example, to know that chronically, so how is the trend of change in terms of this MEQ, right? Yeah, this MEQ, daily MEQ. So one of the way is that probably we can throw all the MEQ and show that by this admission date. So that imagine that there is a timeline here, and we can check that for those different hospitalizations, right, over time. So if we have an average of the MEQ daily, so can we see a trend going up or down, right? So that way, naturally, we're going to think about making a linear regression, right? So, but first, so remember that for this linear regression, we have an assumption, which is that for the outcome, and here it is in MEQ daily, we should check its normality. So if that assumption is violated, then we should not do a linear regression. So let's just check it out. To check the normality, so we're gonna use this Fock univariate, and we're gonna make a histogram, and the rest of the statistics will be reported in the result area. So the result will be like this. If you still can remember, you should check this. For example, this Curtis's, the skewness, right? But let's just jump to this chart here. So obviously this is not a normal distribution, right? Well, if you really want to be more specific in terms of the statistical test, then we should go to, so we should go to this test, right? The Kolmogorov-Smirnov test, right? And that test is having a p-value less than 0.05, so more likely that the data is skewed. Actually, if you look at this histogram, it's going to tell you that actually the data is not normally distributed at all. So what does that tell us? That tells us that actually you cannot directly use this continuous variable of MEQ as the outcome and do a linear regression. That will be wrong, right? But here I'm just show you that if you do want to do linear regression, this will be the code. This will be the data. You have a model. You have this as outcome, and this as the independent variables. And you will have a bunch of reports there, but this is really not my point. My point here is to tell you that it it is improper. Usually, it is improper to check this MEQ over time with this linear regression. You have to figure out other ways to do it. Well, if your result is correct, then you will have the statistics here, and through this statistic courses, I assume that you already know how to read these results. So if you cannot or you have problems, let's talk about it individually. But for example, look at that R square. It is totally a disaster. So in this case, I don't think this regression is is proper anyways. Okay, so this is the part for the linear regression.